Hello, my name is Nina Marroquin. I work with the Office of Student Success as an avid math tutor, and today we shall be discussing how to solve for the gravitational force on a particle due to a rod. To solve for the gravitational force, we use the formula G equals m1 m2 all divided by r squared. G standing for the gravitational constant. M1 is the mass of the first particle, M2 is the mass of the second particle, and R being the distance between mass 1 and mass 2. But whenever we're talking about this formula, we have to understand that this formula only applies to particles. So I have a problem. We're given a particle of 54 kilograms that's at a distance of 25.5 centimeters away from the rod. The length of the rod is 2.5 meters. The mass of the rod is 6 kilograms, and it's asking us to find the gravitational force of this particle due to the rod. Well, the formula we need to use would be F equals G m1 m2 all divided by r squared. But we need to remember, this only applies to particles. That's the only time we can use this formula in this form. But the question's asking us to find the gravitational force on the particle due to this rod. The way we can go about in solving for this problem, we need to use calculus. And we're going to use this form of the formula. F equals the antiderivative of G m lambda over r squared dr. So everyone's still the same. The only thing that's different would be this guy. So lambda stands for the ratio between the mass of the rod to the length. Of the rod. And the reason why we need to find this ratio is because we're trying to break up this rod into individual particles so we can find the total gravitational force acting upon the first particle, as shown in the diagram. So we already know G, m, and lambda are constants because those are the values that were given to us in the problem. So we can write the formula as F equals G m, the ratio between the mass of the rod and its length, times r to the negative second power dr. And then you would just go about the integration. So we get G m, big M divided by L, times negative r to the negative first power. But what are my limits going to be? The limits are going to be from the distance between the particle and the beginning of the rod. And the second, or my upper limit's going to be that same distance plus the length of the rod, because we're trying to find the gravitational force acting upon the m1 between every little particle inside of this rod. So we have to take it to the very last particle. We know all these values, so it's just a simple plug in and substitute. So we know G stands for 6.67 times 10 to the negative 11 times 0.54 times 6, all divided by 2.5, times, oh, and one more thing. Since we have this negative sign here, we can bring it out to the front. It'll make life so much easier when you're doing the algebra. So I have negative everything that I stated before, r, and since we have a negative exponent here, it's the same thing as saying 1 over r. From my first distance, which was the 25.5 centimeters, change that into meters by moving the decimal 2 places to the left, and to my upper limit, which is going to be the same distance, but plus the distance of the length of the rod, which was the 2.5. So here we get negative 6.67 times 10 to the negative 11, 0.45 times 6, all over 2.5, times 1 over, and that should calculate to be 2.755 minus 1 over 0.255. So we get negative 6.67 times 10 to the negative 11 times 0.45 times 6 all over 2.5 times a negative 3.5586. So this gives me a grand total of 3.08 times 10 to negative 10 newtons. And that's it, guys. So once again, my name is Nina Marroquin. I work with the Office of Student Success as an avid math tutor. And today we just finished discussing how to find the gravitational force on a particle due to a non-particle object.